everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem. Solve d power 4 plus 8d squared plus 16 into y equals to 16x plus d. So firstly, let's find order and degree of the given differential equation. Identify the highest derivative. Here d power 4 is the highest derivative, so order will be 4. And the highest power of the highest derivative is our degree. Degree is 1. Or we can just write the differential equation as d power 4y plus 8d square y plus 16y equals to 16x plus 10. We know that d is a differential operator. Then d square will be d square by dx square, and d cube is d cube by dx cube, and d power 4 is d power 4 by dx power 4. Now we can write the differential equation as, write d power 4y as d power 4y by dx power 4 plus 8 into, write d square y as d square y by dx square plus 16y equals to 16x plus 10. Now identify the highest derivative. Here d power 4y by dx power 4 is the highest derivative. So our order will be 4, and the highest power of the highest derivative is our degree. Degree is 1. Now coming to the problem. Solution. Given differential equation, d power 4 plus 8d square plus 16 into y equals to 16x plus 10, which is in operator form. F of d into y equals to q, where f of d equals to d power 4 plus 8d square plus 16, and q equals to 16x plus 10. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by taking RHS to 0, we'll get f of d into y equals to 0, which is a homogeneous equation of the given non-homogeneous equation, and we'll find yp using 1 by f of d into q. Here we have q of some x power k form, right? We'll have like this, right? X power 1 into x power 0. So here, since we are having 1 by f of d into x power k, what we'll do is we'll just find the derivatives of our q, right? Now just compare x power k with x power 1 and x power 0. So here you're having x power 1, right? Leave the lowest degree. Here we are having x power 1. So we'll get only derivative of x power or derivative of q, right? And d power k of q is 0 for k equals to 2, 3 and so on, because you have only power 1 here, right? Highest derivative x power 1, that means highest power you have 1, right? So we'll get derivatives of q for k equals to 1, right? And higher powers from 2, 3, so on, you'll get 0. Derivative of, higher powers of, higher derivatives, otherwise higher derivatives of q from 2, 3, 4, so on becomes 0. Okay, we'll neglect the higher powers from d square, d cube and so on. We'll see it later. Now, let's find yc. We'll find yc using the auxiliary equation. We know that the auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d power 4 plus 8d square plus 16. So by replacing differential operator by m, we'll get f of m equals to m power 4 plus 8m square plus 16. Then our auxiliary equation becomes m power 4 plus 8m square plus 16 equals to 0, right? Now we need to find roots. Let's write m power 4 as m square to the whole square plus, let's write 8 as 2 into 4 into m square plus, let's write 16 as 4 square. So this is of a square plus 2ab plus b square, which is an expansion of a plus b whole square, right? Then we can write the above equation as m square plus 4 whole square equals to 0, right? Which is nothing but m square plus 4 into m square plus 4 equals to 0. Now we equate each factor to 0. We know that when m square plus 4 is 0, we can write it as m square equals to minus 4, then m equals to plus or minus square root of minus 4. And we can write this minus 4 as some minus 1 into 4. Now we can split minus square root of minus 1 into 4 as plus or minus square root of minus 1 into square root of 4, which is equals to plus or minus. We know that square root of minus 1 is I and square root of 4 is 2, right? So we'll get I2, that is plus or minus 2i, right? And for this also we'll get m equals to plus or minus 2i. Finally, we'll get roots. M equals to plus or minus 2i and plus or minus 2i. Repeated pair of imaginary roots, we can say. Therefore, m equals to plus or minus 2i and plus or minus 2i are the roots of our auxiliary equation. Say f of m equals to 0, which are two pairs of complex conjugate. We know that a plus ib is a complex number, then its conjugate will be a minus ib. Likewise, if a minus ib is a complex number, its conjugate will be a plus ib, right? So we call a plus or minus ib as a pair of complex conjugate. What happens if a is 0? We'll get plus or minus ib, right? If we get a pair of purely imaginary roots, okay, since we don't have real part, so we call them as, we are having only part involving I, right? So we call it as purely imaginary. So if you have two pairs of purely imaginary roots or two pairs of complex conjugate roots whose real part is 0, then YC will look like C1 plus C2x into cos bx plus, take another two roots, since two are repeating, right? We have two repeated roots, so we'll get two constants under brackets, okay? Take another two constants, c3 plus c4x into sine bx. Now coming to a complementary function. In our case, we have repeated pair of complex conjugate, right? Then our YC look like C1 plus C2x into, for B equals to 2, you'll get cos 2x plus C3 plus C4x into sine 2x, right? Therefore, YC equals to C1 plus C2x into cos 2x plus c3 plus c4x into sine 2x. Now we need to find particular integral. Now let's find particular integral. We'll find particular integral using 1 by f of d into q. We have f of d, d power 4 plus 8d square plus 16 into q, 16x plus 10. So before going to yp, let's find derivatives of q. Derivative of q is, derivative of 16x with respect to x is 16 plus derivative of constant is 0, which is equals to 16, right? Now, let's find d square of q, which is equals to derivative of q. We have the value of derivative of q, which is 16. Now we need to find derivative of 16. Since 16 is a constant, so derivative of a constant with respect to x is 0. So from here you'll get d cube of q equals to 0, d power 4 of q equals to 0, and so on, 0, 0, 0, right? Which is nothing but, in general, I'll write it as d power k of q equals to 0 for k equals to 2, 3, and so on, right? We have only first derivative value 16 and d power k of q is 0 for k equals to 2, 3, and so on, right? Fine. Now coming to yp. Now let's write it in ascending order. 16 plus 8d square plus d power 4. For my convenience, I am writing like this, okay? Into q. Now, we can take lowest degree term outside. Okay, that means we'll just take the lowest degree term common from all the terms. So here 16 is the lowest degree term. So we need to take 16 common from all the terms. So what I'll do is, I'll just multiply and divide 16 to the next two terms. Okay, now it will be easy to take 16 common, right? If I'll take 16 common from one term, first term and second term, we'll get 16 into 1 plus 8d square plus d power 4 by 16. It's easy, right? Into q. Okay? Or you can also write it as 1 by 16 into 1 plus, I'll write the above two terms as d power 4 plus 8d square by 16. Both are same. Okay, into q. 16x plus 10. Fine. Now we can write yp as, I'll split the denominator or the fraction as 1 by 16 into 1 by 1 plus d power 4 plus 8d square by 16 into q. 16x plus 10. This is equals to 1 by 16 into, now we can write 1 by 1 plus something x as 1 plus x whole inverse into q. So now we are going to perform 1 plus x whole inverse formula. Binomial theorem formula, I can say, is equals to 1 minus x plus x square minus x cube plus so on, right? So we'll get 1 plus d power 4 plus 8d square by 16 whole inverse equals to 1 minus x d power 4 plus 8d square by 16. Now we need to remember only we have d, derivative of q value, okay, and we don't have d square, d cube, d power 4, 5, so on, right? We need to neglect terms from d square, d cube, d power 4 and so on, right? Fine. So here we can take just one term, because in the next term we'll get x square, that is d power 4 plus 8d square by 16 whole square, where d power 4 whole square. See the expansion of d power 4 plus 8d square whole square, you'll get d power 4 whole square plus 8d square whole square plus 2 8 is 16 d power 4 into d square, right? We'll get higher powers. So we can neglect this term and this term also, because here you are having d power 4 and d square. Since d square, d power 4 appears, higher terms from d square, d cube, d power 4 appears in all the terms from here. So we can neglect these two terms also, but it won't good better. We have to show the application, right? It won't look better. So what we'll do is we'll just take the first two times 1 minus x, okay, for our convenience. Now our YP looks like 1 by 16 into expansion of 1 plus x whole inverse, which is 1 minus, we'll just take first term, first two terms, then we'll get 1 minus d power 4 plus 8d square by 16, right, into 16x plus 10. Okay, here we will neglect higher powers from d square, d cube and so on, right? Since d power k of q is 0 for k equals to 2, 3 and so on, right? We have already checked. Now this becomes 1 by 16 into 1 minus 1 by 16 d power 4 minus into plus minus, or better you can just write one more step, okay, without confusion, is equals to 1 by 16 into 1 minus, now you can remove the brackets, minus 1 by 16 d power 4 minus into plus minus 1 by 16 into 8 d square into cube 16x plus 10, right? This equals to 8 ones are 8 twos are, this becomes 1 by 16 into 1 into q is q minus 1 by 16 into d power 4 of q minus 1 by 2 into d square of q. We already know that higher powers become 0, right? D power 4 of q is 0, d square of q is 0. So this becomes 1 by 16 into 16x plus 10 minus 1 by 10 into d power 4 of q is, we already know d power k of q is 0 for k equals to 2, 3, so on, right? So the value of d power 4 of q is 0 minus 1 by 2 into d square of q is also 0, right? Is equals to 1 by 16 into 16x plus 10 minus 0 minus 0, which is equals to 1 by 16 into 16x plus 10. Therefore, our YP is 1 by 16 into 16x plus 10. Now let's write the general solution. The general solution is given by y equals to yc plus yp, right? Then y equals to, we have yc, c1 plus c2x into cos 2x plus c3 plus c4x into sin 2x plus yp 1 by 16 into 16x plus 10. This completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.